Here's a review of how you write both equations and inequalities for the Chapter 2 Algebra 2 test. So kind of working in reverse, where instead of me giving you the equation and you come up with a graph, I'm giving you a graph and you're coming up with the equation. We're going to go through three of the most common ones, a piecewise one, an absolute value one, and then an inequality one. So you're looking at this first one, you see that you have a piecewise function and you're asked to represent it. When you go through and do this, and I'm going to use a couple different colors so you can see it pretty well, first thing you want to do is identify the x value that it's changing. So look right here at your open and closed circle. That is happening at x equals -2. So your inequalities are going to be dealing with before and after -2. So that's how I would start. Identify that x value, and then identify next identify whether you're going to use less than's, greater than's, or where you're going to put the or equal to. When you're heading to the left, that is your less than piece. Notice that that piece has a closed circle. So that means my less than needs the or equal to underneath it. When you look at the ray that's heading to the right, that's your greater than side, it has an open circle, so you want just a greater than sign with no equal to underneath. So that's the first thing you do. That's worth 2 points on your test, is that you can come up with those values and then put the correct inequality. The next step is to go through and figure out the slope and the y-intercept of each ray so that we can write the equation almost like it's two separate problems. So I'm going to look at the left one first, and I'm going to identify its slope. Its slope, you can pick any 2 points. I'll just pick this point and then the end point. It goes down 1, right 2. So my slope is -1/2, or -1/2. And then my y-intercept, this is one where it does help to just kind of continue it. See where it would end up if you kind of just extend it a little bit. Kind of see that it would end up at the origin. So that means it has a y-intercept of 0. Then I'm going to do the same thing for the other piece. Switch colors again. I want to know the slope and the y-intercept. This one, again, pick 2 points. I'm just going to pick the original point and this point right here. This one goes up 1, right 2. So this one also has a slope of 1/2, but it's positive this time because it's going up and right. And it has a y-intercept that's clearly marked. You can see it. I just put a dark circle on it. It has a y-intercept of -2. So it actually crosses over it. You don't have to extend it. So my equations, my ray that's getting to the left, that's this top equation, is going to be -1/2 x. And then you can write +0 if you want, but you don't need to because your y-intercept is 0. And then the one heading to the right has a slope of 1/2. So it's 1/2 x and then -2. So this is the way we write a piecewise. And you really want to work kind of in that direction. Figure out that changing x value. Figure out which one gets the or equal to. You know it has to go somewhere. It just can't go both. And then look at each ray as an individual piece and determine the slope and the y-intercept. The second one is an absolute value one, which is a special type of piecewise. It's going to be a lot easier than the piecewise ones. You only have one equation. What you want to do first with this is you want to identify the shifting. So if you look at 0, 0, you want to figure out how do we get from 0, 0 up to this vertex. To do that, we went left 1 and up 3. So left 1 means in the absolute value bars, you should have an x plus 1. If it went right, it would be an x minus 1. And if you're unsure, you can graph it on your calculator to make sure it's shifting appropriately. To get it to shift up 3, we're going to tack a +3 on after the absolute value. And again, you can check it on your calculator to make sure it's moving the way you expect it to. The number in front of the absolute value, first I want to see if it needs to be positive or negative. And you're looking at the fact that it opens down. Because it opens down, we know it needs to be a negative value in front because that's what flips it upside down. And then finally, you want to figure out the slope. So if you pick the vertex and then you pick this point over here, to get from the 2 points, you have to go down 1, left 2, and then down 1, right 2. So your slope is going to be 1/2. We know it's going to be negative because it's opening down. So there is my absolute value equation. And the nice thing about absolute value equations is you could turn around, graph this on your calculator, and then look at the picture on your calculator, look at the picture that's being presented on your test, and make sure that they're the same. Last one is an inequality writing. So you can see the inequality. These stick out a little bit more because you have shading. You also have dotted or solid boundary lines. So you have a couple decisions you have to make here. You still want to do these the same way, more like the piecewise ones, where the first thing you want to identify is what's the slope and what's the y-intercept. So my slope of this one, and I tried to make 2 points really obvious on here. Here's a point and here's a point. My slope is that I go down 2, right 1. That gives me a slope of -2. And my y-intercept, I also tried to make clear here, is 2. It's this red dot right here. So I know that the mx plus b part is negative 2x plus 2. The only real decision you have to make that's a little different with this one is you have to decide if your inequality is a less than or a greater than, and if it needs an or equal to. First, you want to look at where the shading is. With these, if the shading is above the line, you need a greater than. If it's below the line, you need a less than. So since this shading is above, use a greater than. To decide whether or not it has an equal sign underneath it, you want to look at the dotted or solid. Dotted does not have the equal to. Dotted is saying that that line itself is actually not a solution, just everything above that line. A solid line means you're including it, you put the or equal to. So this one is actually done as is. It is y greater than negative 2x plus 2. And it's another example where your calculator can help confirm it. If you graph this on your calculator, you'll have to change the icon to the left of the y equals, change it to the triangle. We had these different triangles. One was a little upper right-hand triangle. That was what you use for greater than. And then we had that little lower triangle. That's what you use for less than. When you switch that, it will shade it for you appropriately. So if you graph this on your calculator and use that icon, you should see a picture that mimics the picture that's being presented on your test. So it's another way to confirm. So hopefully these three give you a good idea of how you write equations and inequalities when the picture is presented for you.